Good morning. This is going to be kind of a review lesson. So go ahead, title your notes, lesson 99, volume ratio of similar solids. So we've already studied this actually in course 3, but that if you have a ratio of sides of similar polygons A to B, then the ratio of their perimeters would be A to B. The ratio of their areas would be A squared to B squared, and the ratio of their volume would be A cubed to B cubed. That's theorem 99.1. Okay, so with that, for example 1, we're just going to talk about the perimeter of similar solids. So it says you have two rectangular pyramids that have a scale factor of 3 to 2. Determine the perimeter of the smaller pyramid's base. So, for instance, what you're going to do is you're just going to set up that 3 to 2 ratio. So let's find the area of the larger perimeter, which would be 10.5. So it would be 21 over, and we don't know the perimeter of the smaller pyramid's base. And then the ratio is just going to be 3 to 2. So you use the bow tie method, and when you do that, you would figure out the perimeter of the smaller base would be 14 inches. You can go ahead and figure out each side length using the scale factor, but you really don't have to. Okay, so now talking about surface area. The surface area of a smaller pyramid is shown is 54 square centimeters. What is the surface area of the larger pyramid? So we can use that ratio that we see, the scale factor, either larger to smaller or smaller to larger. We can use the 15/6. So we know that what we could do, 15/6 reduces to 5/2. So that's the scale factor of the sides, but it tells us that the surface area of the smaller one is 54. So if we were to go ahead and square the scale factor, we'd figure out that it's a 25/4 ratio of the surface areas. And it tells us the surface area of the smaller is 54. So we would set up a proportion, 25/4 equals x over 54. And when you calculate that out, you would figure out that the surface area of the larger would be 337.5 centimeters squared, because it's surface area. All right, so now we're moving to volume. So it's going to be the scale factor cubed is going to be our ratio. So it's telling us it has the dimensions are a 3 to 2 ratio, basically by looking at the different cylinders. 2 cylinders are shown. They're similar. If the volume of the smaller cylinder is 38 cubic feet, what is the volume of the larger? So we're going to set up that 3 to 2 ratio, but in this case, we're going to cube it. So it ends up being 27/8. And that's the ratio of our volumes. And it tells us the volume of the smaller one is 38. So we're going to set up a proportion, 27/8 equals blank over 38. And then we're going to use our calculator. And so when we use the bow tie method, we would figure out that x equals 128.25, and it's going to be feet cubed. So the last example, application space exploration. Okay, so go ahead and read this. Basically, it's going to be a scale model of a pyramid. And the picture of the pyramid, it's a square pyramid. The base sides are, so I'm going to draw that out the best I can. You guys know I'm not a great drawer. There it is. So there's my square pyramid. And this is the scale model. It has 26 inches on the side of the square. And so and then it has a height of 15. Height equals 15. So if we were to determine the volume of the actual capsule, we first need to figure out the volume of the scale model. So when we would do that, the formula for volume of a pyramid is 1/3 times the area of the base times the height. And the area of the base would be 26 times 26, which is 676 times the height times 1/3. And that's going to equal the volume. And so when you figure that out, the volume ends up being 3380, I believe, inches cubed. And that's the volume of the scale model. But it tells us that the volume of the actual capsule will be dilated by a scale factor of 9. So if we were to set up a proportion, so 9 cubed over 1 cubed, which is just 1, equals the volume of the scale model, which is 3380 inches cubed. And then this right here, we don't know the volume of the actual. So let's go ahead and calculate that. Okay, so when you calculate that, you do 27 times 3,380 divided by 1 if we use the bow tie method. And that would give us a volume of 2,464,020. And this is inches cubed. This is of the actual capsule, but it wants our answer to the nearest cubic foot. So now you guys have to go back in your memory and figure out how to use a unit multiplier to convert inches to cubic feet. So this is something we learned in course 3, 2464020. And then times 3 unit multipliers would give us our answer in feet cubed. So what's the unit multiplier we use to convert inches to feet? Hopefully you all said 1 foot over 12 inches, 1 foot over 12 inches, and 1 foot over 12 inches. So remember, this over here is a 6, but it's really hard to tell. Let me see if I can write it better with this 6. Okay. So now what we're basically doing is dividing 2,464,020 divided by 12 cubed. So when you do that, you would get approximately 1,425.94 feet cubed, and it said to the nearest cubic foot, so you would say approximately 1,426 feet cubed. Okay, so basically that's it for today. That's pretty, it's kind of a review lesson, but go ahead and do the practice, and I picked out a couple of problems for you. Also, we're going to do through lesson 100, and then we're going to do the practice test just as a completion grade, just trying your best, not as a real test, just to see if you need any help with anything. And then from that point, I'm going to pick about 9 lessons after that that I think are the best lessons for the rest of the book. All right, so let me know if you have any questions, and I'll see you tomorrow during the live review. Bye-bye.